Welcome to day 10. In the last episode, our inventory service successfully listened to RabbitMQ and processed orders. But what happens when things go wrong? Imagine a user sends a corrupted order or the inventory database temporarily crashes. If our service simply throws an error, the message is lost forever. And that means a customer paid for an order that will never be fulfilled. Today, we are making our system bulletproof by implementing dead letter queues. When a message fails to process, instead of deleting it, RabbitMQ will safely quarantine it in a special queue so we can inspect it or retry it later without blocking the rest of the system. To build this, we have to modify the inventory service. When we declare our main order events queue, we need to pass it to some special arguments and then tell it, hey, if a message fails, don't throw it away. Instead, forward it to a dead letter exchange. Then we create that exchange and bind it to a new quarantine queue called order events DLQ. So an DLQ is simply an abbreviation for dead letter exchange queue. So open inventory service, then main.py, and update the lifespan. So let me reduce this terminal, and yeah, we go to the lifespan function. Maybe close that so that you can see things better. So after this line 29, I'm going to declare the dead letter exchange and the dead letter queue. So we shall have two variables, DLX for dead letter exchange, okay, which will be equals to await. Okay, I like what AI is suggesting. Okay, and then I'll hit tab. So it says await channel dot declare exchange. I want to simply call it DLX to keep it simple. And this is what I want to do here is remove this, okay, and say AI o underscore picker, okay, dot exchange type, not fan out, but dot direct. I don't know why my editor is not picking up the support. For example, like when I do a dot, okay, I expect the intelligent sense to give me the options, but that's not happening. Anyway, let's continue. Then after that, I need the DLQ, okay, and DLQ is dead letter exchange. No, not dead letter exchange, but dead letter queue. So DLX is dead letter exchange, and then DLQ is the dead letter queue. So DLQ will be equals to await channel dot declare queue, okay, and I can hit autocomplete. Maybe to avoid using abbreviations, I can simply call this the order events DLQ, like I mentioned earlier. Then durable equals true. I'll leave that. Then I can say await DLQ dot bind. Okay, we bind the DLX and the routing key will be equals to order events. So I have to remove this. Okay, yeah, you have to be careful to avoid having issues. So by doing this, we have declared the dead letter exchange and declared the dead letter queue. Now I want to move on to the next line and create some arguments. So this is going to declare the main queue and tell it to route failures to the DLX. So I'll simply hit tab. I like the AI suggestion. So it says X, the data exchange is DLX, and X, the data routing key is the order events. So now I can say Q will be equals to, let me hit tab, await channel dot declare queue. The queue is called order events. Okay. durable equals to true, arguments equals to arguments. And now I can remove what we had previously. Like you see, AI is trying to remove it. So I'll hit tab to complete that. Yeah, not bad. And of course, we had the number 3 step here. I'll just remove it, okay? Because now the ordering has changed. After that, we can now start consuming, print, yield, and close the connection. Yeah, this is nice. If you don't understand the lifespan event in detail, you can check my tutorial on FastAPI. I covered this in detail. See you in the next one. In fact, before that, let me remove this comment. I think now that you understand, there is no need for it. All right. Maybe we need it. Let me keep it, okay? Step 1, connect RabbitMQ. Then I'll say step 2, declare. I want to write it in full. Declare the dead, I want to use lowercase, dead letter exchange and dead letter Q. Okay, in brackets, DLQ, come on, not A, DLQ, and then here, this will be the DLX. Then after that, I can say step 3 right here will be declare the main queue and tell, come on, I want lowercase, and tell it to route failures to the DLX. Okay, this should be good. And then finally here, step 4 is consume messages. Now we shall update the consumer logic, and we're going to wrap the code in the consumer logic in a try except block. And instead of letting I or picker auto acknowledge messages, we take manual control. And if processing succeeds, we call the message.ack method. You're going to see it. But to simulate like a failure today, we will check if the product ID is 999. If it is, we simulate a system crash by calling message.reject. But we're going to have a setting called requeue equals to false. Okay. And it's going to be like the magic trigger, which tells RabbitMQ to kick the message into the dead letter queue. So go into this module, which is inventory service, then main.py, and we go to this other function that we wrote up here, process message, and then we write that simulation. Okay, so now just after this line, okay, line 16, where we're getting the product ID, I'm going to write some code. But even before that, like I told you, I want to wrap everything in the try except block. Let me remove this comment. Some of these comments I want to remove them because I'll assume now you understand what is going on. So I'll come here and say try, then in that, go down, except, can you guess what I'm going to catch? Same thing, okay? Exception as A, like A I suggested. Then here, okay, I'll come to this. Let us first finish this first block. After getting the product ID, I want to check if the product ID is 99. So I'll say if product ID, come on, what is AI doing? Product ID is equals to 999. Okay, so we're going to simulate a fatal error. Let me just put a comment here. This could help you. I'll say simulate a fatal error. And then inside the block, I'll print, okay, let me hit tab, okay. But this time I'll say fatal error simulated crash rejecting message. Again, you can use logging, but we shall talk about logging soon. Then after that, the next line, I will say await. I want to remove this other raise statement and say await message dot reject, like I told you, and you say requeue equals to false. Okay, then I'll just put a comment to guide you. So I'll say reject the message and do not requeue it. Okay, this is key. Do not requeue it. Then after that, another simple comment, I can say this triggers the dead letter exchange. All right. Then, yeah, I can simply return. Okay. Nothing should continue after this. Isn't that nice? Then we go on to the normal business logic. Here, I'll put a comment saying normal business logic. So this is how you can do it. Okay. You can fetch from a database, whatever you're doing, and you'll have great success. Then at the end, okay, we shall say await. Okay, we manually acknowledge the message was processed successfully. Say message dot acknowledge. And to do that here, like I've done before, I want to say manually acknowledge the message was processed successfully. Have I forgotten the spelling? There it is. Okay. And then here, what I can do is await, okay, when there's an exception, message dot reject, okay, and requeue maybe false, okay. Then I'll say if any, I think I might remove these comments, but let me just skip them, okay. If any message, not any message, but if any Python error occurs, if I can spell occurs well, safely dead letter the message. As simple as that. Yeah, so not so hard, not so complicated, but yeah, this is it. So I'm now running the project. Make sure you run it. But there's something, I don't know whether I mentioned it in the previous section about, if you look at line 25, okay, req equals to false. When you set req equals to false, this is what tells RabbitMQ to kick the message in the dead letter queue. Okay, yeah. Now, there's something crucial about RabbitMQ that you must know. You cannot exchange arguments of an existing queue. So because we created the order events queue in D9 without the DLQ arguments, RabbitMQ will throw an error if we try to redeclare it. And yeah, let's try to fix that. In fact, you might see that the inventory service existed. Okay. Yeah, and let me show you. Saying receive the value of DLX of type long string, but current is none. You get. And this is what happened when you try to change an existing queue. So RabbitMQ throws an error if we try to redeclare it with new rules. So we must delete the old queue first. And of course, we can do this easily from the RabbitMQ dashboard. Let's go to the dashboard. Now here, if I refresh, okay, and delete the old queue, do I have the ability to do that? Okay, so we see the delete. Let me delete this queue. Okay, So I think we can now go to, there's this button saying, if I go to queues tab, okay, I'm looking for, oh yeah, I think this is okay. We have deleted, so there's nothing to do. Let's now verify that everything works. It's time to test our architecture. First thing is to rebuild the containers. Give it some time. I hope it's a little bit faster. Okay. Everything looks good. Now let's go to the dashboard. Are you seeing we have order events and order events DLQ? So I'm going to go to the order service API and place a normal order for a product with ID 99 and execute. You see everything is okay. Let me go back to the logs. Okay, we have an issue. Let me try to fix it and then we can continue. But I think the solution to this is simple. Let me close this. Stop all the services. Okay, look at that. We have about 7 services. Stop them. Then I'm going to run docker compose down. Okay, hope that clears the old data. Then run docker compose build. And I hope this gives us what we expect. So I will go to our browser again and execute. So, okay, look at this log, says message already processed. Okay, look at that, says stock reduced, remaining stock for product 99. Okay, that's good. Let me try to do it again. Okay, similar experience. There's a traceback, but yeah, that is something I can process and fix later. Now I'm going to try for a product 999, okay, because I want to simulate the fatal error. Put 9, execute. Let's look at the logs. So you say task was never retrieved. See, it says fatal error, simulated crash, rejecting message. Yeah, but I need to handle this traceback. Okay, but at least you can see that, yeah, it was rejected. Let's go to the RabbitMQ dashboard. So here, if you look at the dashboard, the order events DLQ, we still have one order which wasn't deleted. Okay, so it is sitting safely inside the dead letter queue. No data was lost. Our engineers can inspect it later. So we have successfully built a robust event-driven backend, but as our system grows to 4, 5, or 10 services, how do we track a single request as it bounces between them? In day 11, we shall go into the next phase where we're going to implement open telemetry to visualize our requests. So make sure you subscribe and I'll see you there. So the traceback that you were seeing in the terminal was because I discovered at the top here I was still using async with message.process. Yeah, this handles the process automatically, but we had now begun doing things manually. You get? Like you see this on line 35, and we're also rejecting manually. So we were having double processing and it was causing issues. Now I think if I go to our browser and test, you should see things working fine. So let's try it. Execute. So you see, it says stock reduced, remaining stock for product 99. Okay, everything is okay. So let's try the 999. You see, it says fatal simulated crash rejecting message. So received event. Okay. Yeah, that's good enough. So yeah, make sure you get the latest code from GitHub and review it and play around with it, break it and make it your own. Now, if I go to RabbitMQ, you can see we have 3 messages. And this is because the third one was the one I tested just before I recorded this final section. So let's go into day 11, where we can now visualize our requests. Subscribe and I'll see you there.